In this video, section 5.6, we're going to talk about how you can solve rational equations or equations that involve fractions. There are basically two ways you can solve rational equations, and if you're lucky, you're going to have a proportion, which is going to be probably the easiest way to solve. So if you have a proportion, so a proportion looks like the following. If you have a fraction, let's just call it in general a over b equals another fraction c over d, that is called a proportion, where it's just one fraction equal to another fraction. Now, if that's the case, the easy way to solve is just to cross multiply. And you've probably done this before, and it's a very simple and easy thing to do. In general, if you cross multiply, all we're doing is multiplying the bottom of the first fraction to the top of the second. So that would be like b times c. And then we multiply the top of the first to the bottom of the second. So that's equal to a times d. Now, it doesn't matter the order that you do that. I can write AD on this side and BC on the other side, vice versa. But that's the kind of the name of the game, if you have a fraction equal to a fraction. So you're probably not going to see something quite as simple as that. So let's look at an example kind of like what you're going to be practicing and being assessed on. Let's see something like this. 3 over x plus 1 equals 9 over 4x plus 5. Now, this is a little bit more complicated, but it is still a proportion. I still have just one fraction equal to another fraction, and so that means I can employ the cross multiplication technique. So this is going to change into 3 times 4x plus 5. So I'm going to multiply the top of the first to the bottom of the second, and that's going to be equal to the bottom of the first times the top of the second. So I'm going to write that as 9 in front of the x plus 1. Of course, since we're multiplying, the order that we multiplied does not make a difference. But you'll notice one of the things you're going to have to do here is distribute at this stage. So on the left side, we're going to get 12x plus 15. And on the right side, that becomes 9x plus 9. Now, from here, we're just in Algebra 1 land, right? We're just going to subtract 9x, bring all the variables to one side. We get 3x plus 15 equals 9. Now I'm going to subtract the 15 from both sides, and I end up with 3x by itself on the left equal to a negative 6. And then when I divide by 3, I get x equals negative 2. Now, it's a good idea to check your solutions, as you're going to find out. Sometimes you're going to get a solution that actually doesn't make any sense. And I think in this case, however, if we did take the time to check, it would work. But we're going to take a look at checking some other ones where it doesn't work out so pleasantly. Let's do another example. Let's take a look at example 2. In this example, let's try to solve this rational equation, 5 over x plus 7 over 4 equals negative 9 over x. Now, hopefully the first thing that you notice here is that this is absolutely not a proportion. I don't have just one fraction equal to one fractions. I have two fractions here, so I cannot cross multiply. That goes out the window. All right, now you might be thinking, well, I know how to add these together to get one fraction, and then could we cross multiply? And that's actually not a terrible idea. It would work, but as you know from the last lesson, sometimes adding fractions can be annoying because you have to get common denominators and so on and so forth. But what I would suggest that you do instead is we're just going to find the LCD of all of the denominators in the entire equation, and we're going to multiply all terms by the LCD, or multiply both sides by the LCD. So what we're going to do is this. We're going to find the LCD of the entire equation and multiply both sides by that. So you might be thinking, well, that doesn't seem like a great idea, but you'll see what happens in a second if we do that. Now, if you take a look, all the denominators are already factored. This one only is an x, this is a 4, and this is an x. So the LCD would be just 4 times x. Each denominator is divisible into that LCD. So what we're going to do is we're going to multiply all terms by 4x, or basically we're going to multiply this side of the equation by 4x. So I'm going to rewrite this as 4x times 5 over x plus 7 over 4. And then on this side of the equation, we're going to multiply negative 9 over x by 4x as well. Now notice, I'm not multiplying by 4x over 4x or anything like that. I'm just multiplying by 4x, which is 4x over 1. That's in the numerator of the fraction. And so when I distribute, this is what's going to happen. I'm going to have 4x times 5 over x. Now remember, this is 4x over 1, so it's in the numerator. And then when I distribute the 4x to the 7 over 4, I have 4x over 1 times 7 over 4. And on this side, I already have negative 9 over x times 4x over 1. Now hopefully what you remembered, when you multiply fractions, guys, you can cancel common factors, right? So I have a factor here and a factor here, they get wiped out. And I'm left with just 4 times 5, or 20 for that term, plus, now over here, I can cancel the 4 with this 4. They're common factors over there. And I'm left with x times 7. In other words, 7x equals, now on this guy, I can cancel the x's. Those get wiped out. Those are common factors, and I'm left with negative 9 times 4, negative 36. So hopefully right there you see the value in multiplying all terms by the LCD, because when you do, you're left with an equation that doesn't have any fractions anymore. All the denominators cancel out, and that should always happen if you pick the right LCD, and you're left with an easy equation to solve, hopefully. So from here, it should be a cakewalk. We're just going to subtract 20 from both sides to get negative 56. And then we got to divide by 7. And I get x is, what is that going to be, negative 8. So there's our solution for that guy. Now, let's take a look at one more example here. Let's go to example 3. I'm going to do 1 minus 8 over x minus 5 equals 3 over x. Now, once again, hopefully you notice this is not a nice equation. I cannot cross-multiply to solve this one. I'm going to have to get the LCD, and let's multiply everything by the LCD. So 1 is just 1 over 1, right? So can't do anything with that. X minus 5 cannot be factored down. That is the factor of that term, and the factor here is x. So since there's nothing in common here, the LCD is just going to be the product of those denominators. X times x minus 5 would be my LCD. So that means I'm going to multiply this side of the equation by x times x minus 5, and I got to multiply this side of the equation by x times x minus 5. When I do that, I'm going to distribute right to the 1, which, if you think about it, x times x minus 5 times 1, that's just going to be x times x minus 5. If I distribute it to this term, though, and I'll write this one out because we're learning here, that's going to be minus the x times x minus 5, and remember that's in the numerator over 1, times 8 over x minus 5, right? And on this side of the equation, I have 3 over x times x minus 5. Remember, that's in the numerator over 1. So let's see what cancels. Now, in that first term, where we multiplied just to 1, nothing cancels. It was just multiplying to 1. So what I'm going to do is I'm just going to rewrite that as x squared minus 5x. I'm going to go ahead and distribute that. Now, over here, in this term, there are some factors that cancel. The x minus 5s are the same. So I'm going to wipe those out, and I'm left with just x times 8. In other words, minus 8x on that side. Now, on this side, over here, looking at these terms, there are some common factors that can cancel here as well. The x's both wipe out, and I'm left with just 3 times x minus 5, which I can distribute the 3 and get 3x minus 15. And now, once again, we are in kind of an Algebra 1 scenario. We just have to collect like terms and see if we can solve this. So I'm left with x squared minus 13x on this side equal to 3x minus 15. Now, hopefully you remember when you have a quadratic, we can probably try to solve this by factoring, unless it's a tough problem that's not factorable, but let's see where we're at. Let's subtract 3x from both sides, and while we're at it, let's also add 15 so that we get everything on one side of the equation. These would cancel, giving me 0. On this side, I have x squared by itself. I can add these guys together because they're like terms and get negative 16x, and then I also tacked on that plus 15. So let's see, are there two numbers that multiply to 15 and add to negative 16? Hopefully you're thinking what I'm thinking, and you're, what do we got, negative 1 times negative 15. I think that works, right? They multiply to positive 15 and they add to negative 16. So we can set each factor equal to 0, essentially, using the zero product property, and we get two solutions, 15 and 1. Now, this is where, for sure, you want to think about checking your answers. Sometimes these may not work out. We got x equals 15 and x equals 1. What I'm going to do is just double check. When I look at my original problem, I want to make sure that 1 and or 15 does not make the denominator 0. So if you go back to the original, which was 1 minus 8 over x minus 5 equals 3 over x, if I plug a 1 in here, that's just going to be a negative 4 in the denominator, which is not a problem. I can divide by negative 4, and if I plug a 1 in there, that doesn't become 0, so 1 is okay. If I plug in 15, well, 15 minus the 5 would just make it 10 in that denominator. That's not 0. And if I plug a 15 there, that doesn't become 0. So once again, when I check my solutions, neither of them makes the denominator 0, which is really what you got to look for if you're going to get a false answer. I have one more example that I'd like you to kind of do along with me, just to kind of expose you to different types. And this might be kind of the toughest that you might run into on a quiz or a test. Let's say 6 over x minus 3 equals 8x squared over x squared minus 9. That's an x squared minus 9. I'm sorry, but my exponent there does not look nice. It's not easy to write with this stylus on here. So I have minus 4x over x plus 3. Okay. Once again, I gave you guys a hard one because it's not a proportion. I can't cross multiply here. What I'm going to do is I'm going to get the LCD. Now this one's tricky because I think we can't factor that guy down, we can't factor that guy down, but this denominator can be factored. It's a difference of squares. It's really x plus 3 and an x minus 3, right? So now if we look at our LCD, I have an x minus 3 here, an x minus 3 here, and no other x minus 3s, but the most x minus 3s I need is just the one factor of x minus 3 times, let's see, I also need a factor of x plus 3. So my LCD is x minus 3 times x plus 3. We're going to multiply every term by that. Now, I'm going to show you a trick. This is how I would do it if I were you. Rather than like kind of going like this and showing that I'm multiplying both sides by the LCD, I'm going to go ahead and just kind of write how it's going to look. I'm going to do x plus 3 times x minus 3 in the top times 6 over x minus 3, right? That's supposed to be times, equals, I have 8x squared over, remember we factored that into x plus 3 times x minus 3, and that's going to be multiplied to x plus 3, x minus 3. Remember, every term is going to end up being multiplied by my LCD, minus 4x over x plus 3, and I'm multiplying that by x plus 3, x minus 3. Okay, now this is kind of the fun part. That's the annoying part of doing these, is kind of long and ugly, right? But it gets pretty fast. So in this left-hand side, I can focus on canceling the x minus 3 factors, and that leaves me with just x plus 3 times a 6. Now to save a little time, I'm going to distribute right away and do 6 times x to get 6x and 6 times 3 to get positive 18. Now this is a good term right here, because check out what happens to these denominators. We have the x plus 3's get canceled and the x minus 3's get canceled, leaving only 8x squared alone here. And on this last term here, I can cancel only the x plus 3 factors, nothing else, and it's kind of ugly. I'm going to have to distribute. Now this is tricky. See how there's a negative here? I was really subtracting this term. So when I distribute this 4x, I'm going to really distribute a negative 4x times that x and make it minus 4x squared. And then I'm going to do negative 4x times negative 3. That becomes positive 12x. That's really tricky. I have a feeling that a lot of students would make a mistake and forget to distribute the negative with that 4x. Now we're at the stage where, like magic, we have no fractions left. And all we have to do is collect like terms. So over here, I really have 4x squared plus 12x. And on this side, 6x plus 18. It looks like a quadratic equation. Rather than subtracting 4x and bring everything to the left, how about let's do this? Let's subtract 6x from both sides, right? And let's also subtract 18, because hopefully this is going to be something we can factor and use a zero product property. So we need to set it equal to 0. And on this side, it'd have 4x squared plus 6x minus 18. Now this is a little ugly. I do have a 2 I can divide everything by to make it a little bit easier. So I get 0 equals 2x squared plus 3x, and then negative 18 divided by 2 is negative 9. Now, I can't divide any other common factors out, so let's see if we can do the wheel on this side. If I multiply the first times the last, that's negative 18. In the bottom I get 3, so two numbers that multiply to negative 18 and add to 3. What is that? Positive 6 and negative 3. Let's see if this works here. If I get 0 equals 2x squared, I copy down the first term, then I'm going to use 6 with an x, and then negative 3 with an x, and then recopy that negative 9. Now we're going to group. Out of the first pair I can take a 2x, leaving x plus 3. Out of the second pair I can pull out a negative 3, leaving x plus 3, and we are in business. We can factor this into x plus 3 times 2x minus 3, and if we use the zero product property, x plus 3 equals 0 when x equals negative 3, and 2x minus 3 equals 0 when I add 3 and divide by 2 to get 3 halves. So apparently these are my solutions. However, if we check x equals negative 3, I think we have a problem. Now remember the original, I had 6 over x minus 3. Now that's not the problem. If you plug a negative 3 in there, it just becomes negative 3 minus 3. You're dividing by negative 6. That is not an issue. However, on this term, 8x squared over, remember it was x squared minus 9, but that's the same as x plus 3 and x minus 3, right? And then even on top of that, the other term was minus 4x over x plus 3. If you plug a negative 3 in here and do negative 3 plus 3, that's going to turn into 0 in the bottom, and you cannot divide by 0. That is impossible. It's undefined. Okay. Same thing happens here. If you plugged in negative 3 into this factor, that becomes a 0. Also a problem. So I have to throw this one out. That is extraneous. Do not include that with your solution. However, this answer, 3 halves, is just 1.5. That's not going to be an issue. As long as it's not like 3 or negative 3, right? We're going to be in shape. So this is my answer. Now, let's see if you guys can do these 3 questions on your own. And what I suggest you do is take your time on them. And if you need to refer back to any of the examples from the video, please do it. So here you are. These 3 questions, try on your own and see if you can have them ready to go for tomorrow, and we'll go from there. Thanks for watching.